The Pythagorean theorem was given to us by the Greek mathematician Pythagoras, and it is used with right triangles. It's very well known. In fact, you've probably seen it before. For these figures, the longest side is the hypotenuse. So here we have an example of a right triangle. So it's one that has a right angle. So it's a 90-degree angle like you would see in a square or some kind of a room or something. Next to the right angle are called the legs. So this is leg A and this is leg B. And then across from it is the longest side, which is the hypotenuse, and it will be C in our formula. So in a right triangle, if AB are the lengths of the legs and C is the hypotenuse, we can say, according to the Pythagorean theorem, a squared plus b squared is equal to c squared. All right, so we'll do this for example 1. We're going to find the missing side length, and this is a right triangle. So this is a leg, and this is the hypotenuse. So we're going to say that 5 squared plus 12 squared is equal to n squared. So that means that 25 plus 144 is equal to n squared. So now, after we've done our squaring first with PEMDAS, we're going to now add and get 169 is equal to n squared. And we're ready to solve. To figure out what n is equal to, we'll take the square root of both sides. That'll be the easiest way to do it. And we'll get that n is equal to plus or minus the square root of 169, which would be plus or minus 13. And of course, since it's a length, then we only want the positive, not the negative length. Example B, we have, again, here's our right triangle. X is a leg and 6 is a leg. So we're going to say that x squared plus 6 squared is equal to the hypotenuse, which is going to be 2 square root of 13 squared. So that would be x squared plus 36 is equal to, then when we square this, we're going to have 2 times 2 is going to be 4. And the square root of 13 times the square root of 13 is 13. So that's going to be 52. So x squared plus 36 is equal to 52. To solve it, we're going to need to subtract 36 from both sides. And we get x squared is equal to 16. Then when we take the square root of both sides, we get that x is equal to plus or minus 4, but we really only want the positive length. And for our last example C on this page, again, we have a right triangle. N is a leg, and N is also a leg over here. And we're looking for the hypotenuse, which we're going to call C. So we would say then that n squared plus n squared is equal to c squared. And in order to do this, we're going to then add, so that's going to be 2n squared is equal to whatever c is squared. I'm guessing that we left off a number here. Let's just make one up. Let's say that this then is going to be, we'll call it 10. We'll call it 10. So this is going to be 10 squared, which is 100. And then to solve it, I need to begin, I can't take the square root of both sides yet because this n squared is not isolated. So I'm going to divide both sides by 2 and get n squared is equal to 50. And then take the square root of both sides and get that n is equal to the square root of 50, which is going to simplify. So this is what, 25 times 2. So it's going to be 5 radical 2 for our answer. So I like that number 10 to put in that spot. For example 2, we're going to find the value of k in the trapezoid below. Hint, find the right triangle first. So you can see right here is our right triangle. We're going to be using the Pythagorean theorem, and you see we have one of, here's the right angle right here. So we have one of the legs. We need to figure out what this leg is in order to get k. All right, so this long side here is 20, and this is a square, and this is 15. So that means this section here is 15 as well. And that means if the whole thing is 20, 15, then that means this is going to be a 5 right there. So when we do our Pythagorean theorem, we're going to have 5 squared plus 10 squared is equal to k squared. So that's 25 plus 100 is k squared. So 125 is k squared. Then take the square root of both sides, and we get the square root of 125. So this is going to be then 25 times 5. So we get 5 radical 5 is equal to k. So remember that now that we know how to simplify radicals, whenever we have a square root, we need to simplify it. So we'll stop and go to the next video now.